Hi there, welcome to section 3.1 of John Stewart's Early Transcendentals 9th edition. We are solving question number 21. And so the instructions given by the problem is just to differentiate the function. We've got two terms here. One is 3 times e to the x, and the other one is a kind of nasty looking polynomial. So the trick here is that we have to basically put into a standard formula. And once you have it into a sort of standard format, we can apply the formula. Our basic derivative exponent is just x to the n is equal to the n brought down in front, and you subtract 1 from the exponent. The second term doesn't really match the format of x to the n yet, so we have to figure out what we can do. So the trick is basically if you have a square root of x, it's the equivalent of x to the power of 1/2. And if you have a cube root, it's the equivalent of x to the power of 1/3. If you have a fourth root, it's the equivalent of x to the power of 1/4, and so on. So you might be starting to notice a pattern where, say, the sixth root would be x to the 1/6, the eighth root would be x to the 1/8, and basically whatever the number is in front of the square root is basically what the denominator in your fraction is going to be. And we've got another little trick where if you have an x on the bottom, like 1 over x to the power 1, it just becomes x to the power -1 when you move it up top. If it was 1 over x squared, it becomes x to -2. If it's 1 over x cubed, it becomes x to -cubed, and so on. So you can do basically when you take an exponent from the bottom to the top, you have to negate it. And if you're going to convert a cube or square root, you have to make it into that fraction following that rule. You can even do both tricks at once. So say hypothetically we had 1 over the fifth cube root of x to the 6. Here you get 1 over x to the 6 over 5 as the first step, which is basically just removing the bracket or removing the cubic function. And then we can move it upstairs by making it negative. So these tricks are basically going to help us solve the second half of question 21. So to start with, we're going to take the derivative of the first side and the derivative of the second side, and we're going to basically break it up into two problems. The first problem, if you want to be really technical, you can put the 3 outside of the dx, e to the x, and the derivative of e to the x is simply e to the x over again. So that's pretty much handled on the left-hand side. On the right-hand side, we can take the 4 out, like the same way we took the 3 out, and you just end up and convert this cubic function to x to the power of 1/3. With me so far? So now we can move that x to the power of 1/3 up to the top by making it negative. So here you can see that basically the first function was done, so we just almost wrote it out again. The second function, we moved that x to the power of 1/3 from the bottom to the top by making it negative 1/3. So now we're starting to get closer to our basic derivative rule, which shows, for lack of a better word, that x to the n is equal n x to the n minus 1. Now, the thing is, here we don't really have an n, we have an n to our n is basically negative 1/3, and we still have to subtract 1 from it. The trick there is that basically you can subtract whole numbers if you want, or you can subtract a fraction. If you think of the circle as basically being 1, you can divide that circle into a half, and it's 2 halves. You can divide it into quarters, and it's 4 over 4. You can divide it into eighths, and it's 8 over 8. So really, if you're subtracting 1, you can make it into any fraction denominator you want as long as the top matches. So in our case, because we're trying to subtract by thirds, we would basically divide the circle into 3 parts and say that 1 is the same as 3 over 3. So to start with, to use this formula, we said that our n was 1/3, so that comes out in front. So we have our negative 1/3. We take our exponent, which is negative 1/3, and we try to subtract 1. Now subtracting 1 is the same as subtracting 3 over 3. And in going from the first step to the second step, we basically just multiply that 4 and the negative 1/3 out in front to get you negative 4 over 3. We have that negative 1/3 and we subtract 3 over 3. And we end up with negative 4 over 3, x to the power of negative 4 over 3. And that's basically the answer for the right-hand side. And then if you put it all together, combine the left and the right, you get 3 e to the x minus 4 over 3 x to the power of negative 4 over 3. And that's how we solve this problem. If you have any more questions, or you're looking for a solution to the problem, just send me an email or let me know, and or comment down below, and I'll try my best to solve it. Thank you. Hopefully this was helpful.